For thousands of years, humans have looked up at the night sky and dreamed of reaching the stars. Rockets have taken us to the moon and sent robotic explorers to Mars. But rockets are expensive, dangerous, and inefficient. So what if going to space was as easy as stepping into an elevator and pressing a button? This idea may sound like science fiction, but scientists and engineers have seriously studied a concept called the space elevator. A space elevator would consist of three main parts. First, a base station located near the equator, possibly on a floating platform in the ocean. Second, a counterweight positioned far out in space, about 36,000 kilometers above Earth, beyond geostationary orbit. And finally, the most important component, an incredibly long and extremely strong cable connecting the two. As Earth rotates, centrifugal force keeps the cable stretched tight, similar to how a spinning rope stays straight. Elevator-like climbers could travel up this cable using electric motors, carrying cargo and even people into orbit without the need for rocket fuel. And this is where things become revolutionary. Launching rockets today is incredibly expensive. Because of the physics known as the tyranny of the rocket equation, most of a rocket's weight must be fuel just to lift more fuel. As a result, sending a single kilogram into space can cost thousands of dollars. A space elevator could change that completely. Instead of burning massive amounts of fuel, climbers could be powered by electricity, solar energy, or even ground-based lasers. Some estimates suggest this could reduce the cost of reaching space by up to 95%. But if the idea is so promising, why haven't we built one yet? The answer lies in material science. No known conventional material is strong enough to support a cable tens of thousands of kilometers long under its own weight. Steel would snap instantly, and even extremely strong materials like diamond are not sufficient. The most promising candidate is carbon nanotubes, materials that are incredibly light yet potentially hundreds of times stronger than steel. The challenge is scale. Right now, we can only produce them in tiny lengths in laboratories, far from the thousands of kilometers required. There are also other dangers, such as micrometeorites, space debris, and radiation. However, there may be a shortcut. Because the moon has much weaker gravity, scientists believe a lunar space elevator could potentially be built using materials that already exist today. If that happens, traveling between Earth, the moon, and eventually Mars could become far cheaper and more routine. One day, instead of watching rockets launch, people might simply step into an elevator and ride quietly into space. And when that day comes, the road to the stars might finally begin.